This question is about a simple Atwood machine, which, according to the question, they say that it remains motionless as long as if you attach the equal masses. Alright, so equal masses means these are the identical masses. It means that their weights will be also same. So that's why the resultant force, the magnitude of the resultant force will be 0. So this is mg, and this is also the same magnitude. And don't forget that the tension force is same as well, this tension and this tension. Why? Because both masses are attached with the same string. So as a result, when there is a no resultant force, that means that the it will stay motionless. But that is a situation when we have not attached any small mass with this. As soon as you will attach the small mass, now there will be unbalance of forces, and there will be the resultant force, and that I'm going to show you in the next diagram. Okay students, so let's connect a small mass with this one. According to the question, it has a small mass and m, and it has already a mass capital M. So don't you think now on this side of this string we see that the force that is exerting downward will be more than the tension in a string. Okay, so this weight m plus m into g, this is a total weight of this combined mass, whereas this is a weight of the mg. Okay, so obviously this weight is more than this weight. Okay, because our weight of a small mass is also adding up into each other. And and what about the tension force? The thing is same, the tension will be cancelled out because of the string. So we will write equation for this side of the pulley. Okay, and the resultant force for this mass is the sum of masses times g. This is the weight minus tension. Okay, this is a larger force and this is a smaller force, is equals to m plus m into a. You know very well that we are actually applying Newton's second law, which we say sum of all forces is equals to which mass? The mass for which we are writing Newton's second law equation. So we are writing Newton's second law equation for this mass times acceleration. So basically I have written the same thing. Okay, so we have got one equation, let's say equation 1. Now it's time to write equation for the second mass, the other mass. And for that, the sum of all forces is equals to, now we are writing equation for this mass, which is no mass is attached with the one. Okay, and don't you think for this weight now, because this mg is smaller than the tension force. All right, so we should say the tension minus mg, this is the resultant force or the net force, is equals to ma. Okay, now we have to eliminate the tension T by plugging this value of tension here. Okay, so for this we need to make equation of a tension T for, and then we will substitute its value in the equation 1. All right, I hope you understand that. Now we will put the value here, and when you will substitute the value here, it will be m plus m into g minus into ma plus mg is equals to m plus m into a small m. All right, now you have to solve this equation because we need to find out the larger mass, this m. So let's open the brackets, plus the weight of the smaller object minus ma minus mg is equals to ma plus small m multiplied by a. Okay students, so you can see that this term is cancelled out by this term, and then you can take this term on the other side and it will become mg minus ma is equals to, let's take this term on the other side, So it will become positive and ma plus ma. Okay students, now mg minus ma is equals to 2ma. We wanted to find out the larger mass, so that's why the larger mass will be equals to weight of smaller object minus uh, small ma divided by 2a. So this is our final answer, and I'm sure it should be available in options, and that is none other than this one. So the a is the right answer.